Hello folks, you are welcome to my channel. Let's solve this. It reads, the terminal side of an angle theta in standard position passes through the point A15. We have to find the value of the 6 trigonometric functions of the angle. Join me, let's solve it. So solution. First of all, you have to draw your Cartesian plane to locate your point A15. So we draw our Cartesian plane, y-axis and our x-axis. The x-axis, we have the positive side and we have the negative side. The y-axis, we have the positive side and we have the negative side. Okay, in this case, the 8 is positive, meaning it will be found somewhere here. The 15 is positive, meaning it will be found somewhere here on the y-axis. Okay, so when we join this, they will be meeting here, meaning our point lies here, 8, 15. And the question says, the terminal side of the angle theta in standard position. The standard position always is from the origin. So they said it passes through the point. So from the origin, passing through the point, and the theta in standard position always lies on the x-axis. In this case, the positive x-axis. Very good. Now look at your question. It says trigonometric functions, 6 trigonometric functions. Trigon means triangle. Metric means measurements. That's metron in Greek. Metron, trigon in Greek, triangle. Metron, measurement, so triangle measurement. So in this case, we need a triangle. So we can join this to form what? A triangle. By this case, the triangle is a right angle triangle. And this right angle triangle, you have a distance of 8 units. That's a length of 8 units. From here to here, 8. And from here to here is 15 units. So our side here is 8 and our side here is 8. You have only 2. But for right angle triangle, you need 3 sides for it to be complete. So when we have 2 sides with one unknown, you use Pythagoras theorem to get the other side. So let's do that. So that's hypotenuse square, let me write it here, equals opposite, let me use O, plus adjacent, let me use A, so A squared. Our H here is the longest side. That's what we are finding for. Our opposite is the angle opposite. If the length is facing the angle, or the angle is opposite that side is known as opposite, where the angle is facing. So 15 squared plus adjacent is equal to 8 squared. 15 squared will give us 225 plus 8 squared, which is 64. So when you sum this, you are going to get 289. 289. Meaning our hypotenuse square equals 289. Now we need hypotenuse. So you have to square root both sides. So as the square root will cancel the square. So our hypotenuse will be equal to square root of 289. Is it not 17? 17, good. So 17 units. So the length here is 17. In that case, you can write your data down. That is hypotenuse H equals 17. Your opposite the angle, so opposite equals 15. And your adjacent equals 8. Now your 6 trigonometric ratios. For the 3 main ones, we have a mnemonic in remembering it. Very, very simple. That's SOHCAHTOA. SOHCAHTOA. Very, very easy. Meaning, our S here is for sine. So sine has a ratio of opposite and hypotenuse. So sine theta equals opposite over hypotenuse. And our cos theta will be equal to adjacent over hypotenuse. And our tan theta will be equal to opposite over adjacent, so O over A. If you know this, then you can plug in the data, the values which is being given. So our sin theta here, opposite, which is 15, so 15 over hypotenuse, which is 17, so 17. Our cos theta, which is adjacent over hypotenuse, so 8 over 17, 8 over 17. Our tan theta, which is opposite over adjacent, our O is 15, our adjacent is 8, so 15 over 8. Now you have to check where your point was lying, the quadrant, very, very important. You have to check where the point lies, the quadrant it lies in. So this is your first quadrant, because for trigonometry it's measured in anti-clockwise direction. So this way, this direction. So this is your first quadrant, your second quadrant, your third quadrant, and your fourth quadrant. In this case, your point lies in the first quadrant, meaning all the ratios should be positive. So they are all positive, meaning our answer here is correct. But remember, the question is 6 trigonometric functions. So we have 3 here. So the other 3 is the reciprocal of these ones. So let's do that. So sin theta, the reciprocal is cosec theta or CSC theta. So CSC theta. Cosecant is shortened as CSC. So CSC theta equals reciprocal. So 17 over 15. Our cos theta has its reciprocal called sec theta, which is, so you flip it, 17 over 8. And our tan theta, its reciprocal is cos. So cos theta equals, you flip it reciprocal, so 8 over 15. So these are 6 trigonometric ratios. That they are the values of the 6 trigonometric ratios. Thank you very much. If you do enjoy this video, please subscribe. Tell your friends to also do so. Thank you very much.